Good afternoon students, I am Kavita Monga, lecturer physics from Government Polytechnic College, Khuni, Majra. Today we will study about direct current circuits, DC circuits. In this chapter, in this topic, the topics which we will cover are what are advantages of electricity, then properties of electric current, then concept, definition, units of current, voltage, resistance, potential difference, EMF, power, electrical energy, and finally we will define AC and DC current. So all these topics we will cover today. What are advantages of electricity, then properties क्या है current की, then current, voltage, resistance, potential difference, EMF, power, इन सब की definitions और इनके units, then what is electrical energy, and finally AC और DC current क्या होते हैं, what is difference between AC and DC current. So to start with, first concept of current electricity. So what is current? The branch of engineering which deals with the study of electrons or charge in motion is known as current electricity. So what is current or what is electricity? This is flow of electrons or charge. So electrons or charge in motion. So study of this branch of engineering, this is called current electricity. So current electricity has assumed a great importance in this fast developing engineering world. It has made possible many applications such as electric motors, electric lamps, heaters, electric trains, electronic devices like used in communication, etc. Then what are advantages of electrical energy? There are different forms of energy. हम thermal energy भी use करते हैं, कोयला जलाते हैं, wood जलाते हैं. Then chemical energy is also there. But what are the advantages of electrical energy? Electrical energy के क्या फ़ायदे हैं, इसके क्या advantages हैं? So number one, it is a convenient form of energy. So very convenient form. It can be easily converted into other forms of energy. So electrical energy can be easily converted into other forms of energy. Then it is easy in handling, इसको handle करना आसान है. Whenever it is required, it can be taken with the help of conductors. So conductor से हम transfer कर सकते हैं, transport कर सकते हैं इसे, and thus can be used for various purposes. So this form of energy, it is easy in handling. Whenever it is required, it can be taken with the help of conductors. For example, copper and aluminium wires, and thus can be used for various purposes. Then it is a cheaper form of energy. cheap है. Electrical energy can be easily produced. So इसको आसानी से produce कर सकते हैं, and it is a cheaper form of energy. The next advantage is cleanliness. ये साफ सुथरी है. It is very clean form of energy as compared to other forms of energy. It is free from smoke, fumes or poisonous gases. Like in chemical energy, अगर हम chemical use करते हैं, उससे energy लेते हैं, then pollution is there, smoke, fumes and poisonous gases are there. So this form of energy, it is very clean form of energy. Then next is what are the properties of electric current. Electric current की properties क्या हैं? So different properties are there. So number one, it is heating properties. An electric current heats any body through which it passes. So current जिसमें से भी pass करता है, जिस body में से pass करता है, उसको गर्म कर देता है, heat कर देता है. For example, devices such as stoves, electric stoves, radiators, water heaters, welding and electric lamps, these are all examples. So whenever current pass, heat is produced. So heating properties of the current. Next is magnetic properties. So what are magnetic properties of current? An electric current flowing through a conductor produces a magnetic field. So when current flows through a conductor, a magnetic field is produced. These properties are utilized in a number of electrical machines such as electric generator, electric motors, etc. सो ये जो प्रॉपर्टी है ये बहुत सारी मशीन्स में यूज़ होती है, फॉर एग्जांपल जनरेटर्स एंड motors. Then after that another property of current is electrochemical property. So heating property, magnetic property, and next one is electrochemical property. An electric current causes chemical action when passed through an electrolyte. So अगर किसी electrolyte में आप current pass करोगे तो there will be a chemical action. For example इसके जो examples हैं electroplating, electrolytic refining, battery industry and manufacture of various synthetic. So all these are examples of electrochemical property of the current where this property is utilized. All these are applications: electroplating, electrolytic refining, battery industries and manufacture of various synthetic. So these are various properties of current. Now next let's define what are free electrons. We say what is current, we will define current that it is motion of electrons or charges. So it is motion of free electrons. Now what are free electrons? So let's define what are free electrons. The electrons which can be easily removed or detached from an atom are called free electrons. So वो electron जिनको किसी atom से easily remove या detach किया जा सके वो they are called free electrons. In certain substances, especially metals, so especially in metals, the electrons in the last orbit are so weakly bound in their nucleus that they can be easily removed or detached. So जनरली क्या होता है मेटल्स में, जो आउटर मोस्ट शेल होती है न्यूक्लियस के बाद जो आउटर मोस्ट शेल होती है उसमें जो इलेक्ट्रॉन होता है इट इज़ वीकली बाउंड. सो वीक होती है इंटरेक्शन उसकी, वीक बॉन्ड होता है एंड इट कैन ईजीली बी रिमूव. उसके लिए कम एनर्जी चाहिए होती है उसको रिमूव करने के लिए या डिटैच करने के लिए. सच इलेक्ट्रॉन्स आर कॉल्ड फ्री इलेक्ट्रॉन्स. तो ऐसे इलेक्ट्रॉन्स को फ्री इलेक्ट्रॉन कहा जाता है. इफ़ वी लुक एट द स्ट्रक्चर ऑफ कॉपर एटम देयर इज ओनली वन इलेक्ट्रॉन इन द लास्ट ऑर्बिट. सो दिस single electron, this is free electron, it can be easily detached. So now next see electron motion in a conductor with and without an electric field. So अगर आप विदाउट इलेक्ट्रिक फील्ड देखोगे इलेक्ट्रॉन मोशन इन एन कंडक्टर, एक कंडक्टर के अंदर जो इलेक्ट्रॉन मूव कर रहा है फ्री इलेक्ट्रॉन वो जिगजैग पाथ है, कोई इसका पर्टिकुलर पाथ नहीं है. And we say net displacement is zero. So net displacement is zero means net current is also zero. अगर इलेक्ट्रॉन मूव कर रहा है हैप्पैज़र्डली मूव कर रहा है उसका कोई डेफिनेट पाथ नहीं है तो देन means in the absence of any external field the net displacement is zero. That means the net current is zero. But when some particular field is there, so in the presence of that external field, so there will be some net displacement of the electron. This free electron will move, but under the influence of this external electric field some net displacement will be there. So now just see how electron moves. Free electron move inside a conductor, analogy of a charge moving in a conductor. So this end of the conductor is at high volts 12 volts, other end is at 0 volt low volt. So we know the charge flow from high potential to towards low potential. So the electron or the free electron will move from high potential towards low potential and in this way it will make its path. These represents different atoms. So this is the path of a free electron inside a conductor. So now next let's define what is electric current. Electric current क्या है, इसकी units क्या है. The rate of flow of charge is called electric current. So what is the definition of electric current? This is the rate of flow of charge. If Q is the net charge, charge को हम symbol देते हैं Q का, Q. T is time, then I stand for current. So current I, this is given as Q upon T. Q stand for charge and T is time. So if Q is the net charge that passes through any section of a conductor in time T, then current I is given by, then current I, this is given as Q upon T. So this is equal to Q, it can be replaced by N into T, where N is number of electrons and E is charge on a single electron. So the total charge Q, this is given as N into E. N is number of electrons present and E is charge on each electron. Okay, so I current, it is equal to Q upon T numerically or mathematically, or this is equal to NE upon T. SI unit of current is ampere and its symbol is capital A, and 1 ampere, this is equal to 1 coulomb upon 1 second. So unit of current is ampere, unit of charge is coulomb, and unit of time is second. So 1 ampere, this is equal to 1 coulomb upon 1 second, and this is equal to, if we write this in terms of number of electrons, so just see here, I is Q upon T, or this is NE upon T. So if we write I in terms of NE upon T, then N number of electrons will be 625 into 10 power 16 electrons. So अगर इतने electrons होंगे तो उतने electrons का जो charge है that is equal to 1 coulomb. So 1 ampere, this is 1 coulomb upon second, or in other words, this is if 625 into 10 power 16 electrons cross a point in 1 second, then the current flowing is 1 ampere. So 1 ampere of electric current is said to be flowing through a wire at any section if 1 coulomb of charge or 625 into 10 power 16 electrons pass through it in 1 second. So next, let's see what is the direction of current. So conventional direction of current. Current कहाँ से कहाँ को flow करेगा? Just see. It is conventional to choose the direction of current to be in the direction of flow of positive charge. So जिस direction में positive charge flow कर रहा है, that is the conventional direction of current. So the direction of current will be opposite to the flow of electrons. Naturally, electrons and positive charge, they will move in opposite direction. So the direction of current is opposite to the flow of electrons. The current is assumed to flow from the positive terminal of the source through the electric circuit and then to the negative terminal of the source. So conventionally हम क्या लेते हैं कि करंट की डायरेक्शन क्या है? अगर हमारे पास बैटरी है, एक सर्किट में हमने बैटरी लगाई है, तो it is from the positive terminal of the battery towards negative terminal of the battery. So what is the conventional direction of flow of current? This is always in the direction of positive charge, or you can say opposite to that of electrons, or you can say this is from positive terminal of a battery to the negative terminal of a battery. So now just see in this diagram, conductor with conventional current moving from high electric potential to low potential. So charge or current, it flow from high potential to low potential. So the current I symbol is for current. A, this is one side of a conductor phase. So the potential difference across these two ends is V. V is potential difference, L is length of the conductor, I stand for current. So the current flow from high potential towards the low potential. So this is the direction of flow of current. Again see here, the current flow from positive terminal of the battery towards negative terminal of the battery. So positive terminal is at high potential, negative terminal is at low potential. So the current flow from high potential or positive terminal towards the negative terminal of the battery. So in this diagram also you can say the positive charge, the direction of positive charge is that of the current. Now let's compare conventional current with electron current. So conventional current is direction of positive charge. Naturally electron current will be in opposite direction. So the direction of conventional current is in the direction in which the positive charge flow. In gases and liquids, both positive and negative ions move. Only negative charges, that is electrons, move through solids, and this is referred to as electron current. Just see in this diagram, this is positive terminal of the battery and this is negative. So the direction of conventional current is from positive terminal towards the negative terminal, whereas the direction of electron flow or electron current is in the opposite direction. So next let's see what are the different types of current. So two types of current are there. One is alternating current जिसको हम AC भी कहते हैं, and another is direct current जिसको हम short में DC भी कहते हैं. So AC and DC, two types of current. So what is alternating current? Just see, if the magnitude and direction of current changes continuously at regular intervals of time and graph between current I and time t is a sine curve, then the current is known as alternating current or AC current. So if magnitude and direction they are continuously changing, okay, and the graph between I and t, this is a sine curve, then the current is alternating current. And what is direct current? If the magnitude and direction of current remains constant, magnitude as well as direction of current remains constant all the time intervals, and graph between current and time is a straight line, then the current is known as a direct current. So the graph between I and t is a straight line, so it is a direct current. So just see here, in direct current or DC circuit, the current flow in one direction only. So the graph between I and t, this is a straight line, this is DC current. In an alternating current or AC circuit, the direction of current flow through the circuit changes at a particular frequency. The frequency used is 60 cycles per second or 60 Hz. So generally जो घर में हम AC current use करते हैं उसकी frequency 60 Hz होती है, 60 cycles per second or 60 Hz. This diagram, this is graph between I and T, and this is a sine curve. So this represent AC current, this is DC current and this is AC current. Straight line means DC current है और एक sine curve है, तो this is AC current. Now next let's define what is voltage or potential. Voltage क्या होती है और potential क्या है? Just see, potential is that electrical condition of a body which determines the flow of charge when two charged bodies are connected by an electrically conducting wire. So ये वो प्रॉपर्टी है, वो कंडीशन है जो हमें ये बताती है कि चार्ज किधर से किधर को फ्लो करेगा. अगर दो चार्ज बॉडी को कनेक्ट कर दिया जाए विद अ कंडक्टिंग वायर, देन द चार्ज विल फ्लो फ्रॉम हाई पोटेंशियल टू लो पोटेंशियल. जो बॉडी हाई पोटेंशियल से पे है उससे द चार्ज विल फ्लो टू द बॉडी एट लो पोटेंशियल. So potential is that electrical condition of a body which determines the flow of charge when two charged bodies are connected by an electrically conducting wire. Potential means the ability to do work. A charged body has a capacity to do work in moving other charges. जो एक चार्ज बॉडी होगी जिसको हमने चार्ज किया होगा, it has capacity to do work in moving other charges. So in other words, a charged body has potential. So what is now potential? Potential is ability to do work. A charged body has potential means a charged body has ability to do work. So electric potential at a point is the work done in bringing a unit positive charge from infinity to that point. So हम किसी point पे बोलेंगे कि कितनी electric potential है, वो कितनी है. So that electric potential that is equal to the work done in bringing a unit positive charge from infinity to that point. And finally electric potential is a scalar quantity. ये एक scalar quantity है, means it has only magnitude and no particular direction. So next electric potential क्या है? So this is equal to work done in bringing 1 coulomb of positive charge from infinity to a point. So what is this? This is equal to electric force on 1 coulomb charge multiplied by the distance moved, or you can write this is E into D. What is E? What is E? This is electric field intensity or electric field strength or electric field. So substituting the value of E, this comes from Coulomb's law, जो हम already पढ़ चुके हैं. Coulomb's law डिस्कस हो चुके हैं, आपने देखे होंगे, आपको आते होंगे. So this formula of E, this is from Coulomb's law. So E, this is given as Q upon 4 pi epsilon naught epsilon r into d square. Multiply this with distance d, then this V, electric potential, this is V, its symbol is V. So this comes out to be Q upon 4 pi epsilon naught epsilon r into d. So ये फार्मूला है अगर हमें V कैलकुलेट करनी हो. So V is E into D. V is E into D. What is E? E is force experienced by a unit positive charge. Force experienced by a unit positive charge is E multiplied by D, and this comes out to be Q upon 4 pi epsilon naught epsilon r into D. So, and its units are units of this quantity, potential, coulomb upon farad. This Q, this is measured in coulomb. उसके अलावा ये सारे कांस्टेंट्स हैं 4 पाई एंड एप्सिलॉन नॉट, all they are constant. Epsilon naught is measured in farad upon meter. So substituting all these values, coulomb, then farad upon meter, and then meter square, उसको कैंसिल करने के बाद you get coulomb upon farad. So coulomb upon farad, this is equal to volt. So the unit of potential is 1 volt. So 1 volt, this is also equal to 1 coulomb upon 1 farad. So what is 1 volt? Now we can define what is 1 volt. 1 volt, this is electric potential at a point is 1 volt if 1 joule of work is done to take 1 coulomb of charge from infinity to that point. So potential 1 volt कब होगी? जब 1 joule of work is done to take 1 coulomb of charge from infinity to that point. So this is how you can calculate potential. Potential is equal to work done, or you can say this is E into D. E is electrical intensity. Substituting its value, you get the value of V, Q upon 4 pi epsilon naught epsilon r into D. Now in this figure, we can see that like the water flow from high pressure to low pressure, all of us we know that water flow from high level to low level. High level पे pressure ज़्यादा होगा, so the water flow from high level towards low level. Similarly, charge or current, it flow from high potential towards low potential. So positive terminal of battery is at high potential, so the charge flow from high potential towards the low potential, and we say the charge body has ability to do work, which is potential. So what is the work done? Work done is that this bulb is glowing. So the current is flowing, charge is flowing from high potential towards low potential, and this is the work done. So this is analogy. Water at high pressure, the higher the pressure, the more is the water flow. Similarly, the higher the voltage, the more is the current flow. Water flow rate, जो water flow होता है, that is in gallons per minute, और जो current का rate है, that is in coulomb per second. So what is current? This is rate of flow of charge. Rate of flow of charge, charge flow rate. So its units are 1 coulomb upon 1 second, which is equal to 1 ampere. So like just like the water flow from high pressure to low pressure or from high level to low level, in the same case the current or charge move from high potential to low potential or high voltage to low voltage, and current is rate of flow of charge. This is coulomb upon second, and this quantity is equal to 1 ampere. Now just see what's happening. Electric charges can flow in conductors. These are Coulomb's law. Like charges repel and unlike charges attract. Because of the chemistry inside the battery, there is a voltage set up across the terminal. So इसके अंदर जो भी हम chemicals डालते हैं, उसकी वजह से जो reaction हो रहा है, chemical reaction, so the result is that some voltage is set up. So this is at positive potential and this side is at negative potential. So जब हम उसको join करते हैं through some conductor, the charge start flowing from positive terminal towards negative terminal, or you can say from high potential towards low potential. So this is what's happening, how the bulb glows. So from high potential towards low potential. So what's really happening? Electrons are flowing out of bottom of the battery around to the top. Since they are negative, the direction of the current flow by convention is opposite to their physical movement. It is much easier to think of positive charges flowing even though they are slightly, this is slightly fictitious. So we say the direction of current is the direction of flow of positive charge, and electrons, they are moving in opposite direction. Next, now let us define what is potential difference. अभी हमने जो previous slides देखी थी उसमें हमने we defined what is potential और voltage. Now next thing is what is potential difference. So what is electrical potential difference? This is the difference, potential difference between 2 points is equal to the work done in moving a unit positive charge from the point of lower potential to the point of higher potential. So आपको unit positive charge लेके जाना है from low potential to high potential. So the amount of work done जितना आपको करना पड़ेगा that is equal to the electric potential difference, और इसके units भी volts ही होते हैं. The units of electrical potential difference are volts. Again we can define what is 1 volt. So electric potential difference between 2 points is 1 volt if 1 joule of work is done in moving 1 coulomb of charge from one point to another. So जैसे potential को define किया, in the same way potential difference, and now this is difference between 2 points. कि हमें we have to carry a charge from one point to another point, and these 2 points they have different potential. So the work done in carrying or moving a unit positive charge from point of lower potential to higher potential, this is equal to potential difference. Its units are also volts, and to measure potential difference, the instrument which we use, this is voltmeter. So voltmeter is used to measure the potential difference between 2 points. Now next let's define what is potential gradient. Another term is potential gradient. So the rate of change of potential with distance is called potential gradient. So change in potential over the distance. Distance के साथ अगर potential change हो रही है तो उसको हम potential gradient कहते हैं. So the potential gradient, that symbol says G. This is given as change in potential upon the distance. All this is equal to V1 minus V2 divided by S, where S is the distance, V1 and V2 they are potential at the 2 points. And the unit of potential gradient is volt upon meter. So this potential difference, this is measured in volt, and distance is measured in meter. So the unit of potential gradient is volt upon meter. Now next let's define what is EMF or electric motive force. After that we will distinguish between what is potential difference and what is electromotive force. दोनों में difference क्या है? So now let's define what is EMF. EMF or electromotive force. It is defined as the potential difference between two terminals of a battery or cell when no current is being drawn from it. So किसी भी source के, source means battery और cell, किसी भी source के जो दो terminals के बीच में potential difference है, when no current is being drawn, that is equal to EMF. उसको EMF कहा जाता है. जैसे कि cell और battery is in open circuit. So example है कौन से sources जैसे cell और battery हो, then it is also measured by voltmeter. ये potential difference भी हम voltmeter से ही measure करते हैं. Its unit is also volt. इसका SI system में unit भी volt है. It is not a force. ये force नहीं है, but it is work. It is actually potential difference only. So it is not a force but work that a source can do to move charge in the circuit. So EMF, this is work done upon charge. So next let's see what is the difference between EMF and potential difference. So what is EMF? It is the difference of potential between two electrodes of a cell or battery in open circuit. Open circuit means कुछ भी लगाया नहीं गया है, it is open. Circuit is not closed, and the difference of potential between two terminals of cell or battery, this is EMF. And what is potential difference? It is the difference of potential between any 2 points in a closed circuit. So between any 2 points in a closed circuit जो difference है potential difference, potential का difference, that is potential difference. और जो सेल के या बैटरी के या जो सोर्स है कोई भी, उसके जो दो टर्मिनल्स के बीच में पोटेंशियल डिफरेंस है, दैट इज EMF. The term EMF is used strictly for the source or supply of electricity. जो इलेक्ट्रिसिटी सप्लाई करने का सोर्स है, सोर्स ऑफ सप्लाई ऑफ इलेक्ट्रिसिटी, एग्जांपल हो गया सेल और डायनमो. सो EMF खाली सोर्स के लिए टर्म यूज़ होती है. एंड दिस पोटेंशियल डिफरेंस इट एग्जिस्ट थ्रू आउट द सर्किट. ये सर्किट में किन्हीं भी दो पॉइंट के अक्रॉस देखा जा सकता है. EMF इट डज नॉट डिपेंड अपॉन द रेजिस्टेंस ऑफ द सर्किट. ये सर्किट की रेजिस्टेंस पे डिपेंड नहीं करता.